mathematics. Student, in our last video, we discussed the concepts of increasing and decreasing functions. And we did small problems in last video. In today's video, we'll discuss the problems in details. So let us start the application of derivatives, second topic, that is increasing and decreasing. But this video we will discuss only problems. The first problem, find the interval in which the function f of x is equals to 2x square minus 3x. F of x is equals to 2x square minus 3x is a first sub question, increasing, and second sub question, decreasing. Student, in this question he is asking us to find the interval. He is asking us to find the interval in which this function is increasing as well as decreasing. So here, since he is asking us to find the interval, so we'll use the concepts of wavy curve. Solution: given f of x is equals to 2x square minus 3x. So in this concept, we must differentiate the function with respect to x. So differentiate f of x with respect to x. So the derivative of f of x is f dash of x, and that is equals to 2 is a coefficient here, as it is derivative of x square. It is 2x minus, as it is 3 is a coefficient, as it is, then derivative of x, it is 1. So finally my f dash of x is equals to 4x minus 3. To find the intervals, I should consider that f dash of x is 0. If my f dash of x is equals to 0, that gives 4x minus 3 is equals to 0. With this, I will get the value of 4x is 3, then x is equals to 3 by 4. I am getting the value of x as 3 by 4. So let us draw the number line. Towards my left hand side it is minus infinity, and towards my right hand side plus infinity. Then this is a positive value. So let me write this value somewhere closer to infinity, 3 by 4. And in our last video, we discussed the wavy curve already. So I hope you people understand this problem. This is our first interval, minus infinity to 3 by 4. The next is 3 by 4 to plus infinity, because I got only one value of x. If you are getting one value of x, we get two intervals. If we get two values of x, we get three intervals, and so on. And here, student, the intervals are open intervals. We cannot take closed intervals. Now here, if you see the function, the highest power of x is positive. The highest power of x here is x square, and its sign is positive. So towards our right hand side, we should mark the sign as plus and minus in this intervals. So whenever I mark plus sign in that particular interval, the given function is increasing. And in the other interval, that is wherever I mark negative, in that particular interval, this function is decreasing. So I can write the conclusion that first conclusion, f of x is increasing in the interval 3/4 comma infinity, because there is a plus sign here. Second condition, f of x is decreasing in the interval minus infinity comma 3/4. So this is the final answer, because it's just asking us to find the interval, and we got the intervals. We did in the last problem, but here it is a cubic equation. Okay, let us try to solve this. Given f of x is equals to 2x cube minus 3x square minus 36x plus 7 plus 7 First, let me differentiate this function with respect to x. Differentiate f of x with respect to x. So derivative of f of x is f dash of x is equals to 2 is a coefficient as it is, no changes. Derivative of x cube. Derivative of x cube is 3x square minus 3 as it is. The next is derivative of x square is 2x minus 36 is a coefficient as it is. Derivative of x is 1 plus derivative of any constant is 0. So finally, our f dash of x is equals to 6x square minus 6x minus 36. So now I should take f dash of x is 0. If f dash of x is equals to 0, then this gives 6x square minus 6x minus 36 is equals to 0. Since here these three terms are divisible by 6, or I can easily take 6 common here, or I can divide by 6. Divide 6 on both sides here. If I am dividing 6 to this term, then 6 and 36 gets cancelled by 6, as well as 0 divided by 6 is again 0 here. Finally, I will get x square minus x minus 6 is equals to 0. Now I must factorize this because it is a quadratic equation. So I know that there are two values of x here. So what could be the factors here? So x square. If I multiply any two number, I should get minus 6 is the answer. If same two number I am adding, then I should get minus 1. So the fractures are minus 3x plus 2x. Minus 3 plus 2 is minus 1. Minus into plus minus 3 2 is 6. Minus 6 is equals to 0 here. So x is common in these two terms. Then one time x left out and minus 3 is left out. Plus 2. Then here, if I remove 2, x is left out. Minus 2 times I remove from this. And left out is 3 is equal to 0. So now x minus 3 is common. What is left out here? X plus 2 is left out here is equals to 0. Then next is x minus 3 is equals to 0 and x plus 2 is equals to 0. With this I can write x is equals to 3 and with this x is equals to minus 2. Students, since we got a quadratic equation after differentiation, so here we are getting two values of x. But these two values I should mark on a number line to find the intervals. So we'll draw the number line here. So as I said in the last problem, towards my left hand side it is minus infinity and towards my right hand side it is plus infinity. Minus 2 is little bit closer to negative infinity, mark somewhere here, and plus 3 is closer to plus infinity, mark somewhere here. So let me draw the intervals now. 3 to infinity is one interval, then minus 2 to 3 is another interval, the last one is minus infinity to minus 2. So process remains same. In Vedic, we should check the sign of highest power of x. The highest power of x here is q and its sign is positive plus 2. Then the markings are from our right hand side, we should mark plus, minus, plus, alternate signs. Now here, there are two intervals which carries positive signs. So in this two intervals, this function is increasing. And one interval has negative sign. This interval, the function is getting decrease. So the conclusion is, first one, f of x is increasing in the interval minus infinity comma minus 2. Union I should write because I need both. So I'm combining these two intervals. Union open interval 3 comma infinity. In these two intervals, the function is increasing. And the second one, f of x is decreasing in the interval minus 2 comma 3. Minus 2 comma 3. This is the final answer. Increasing in only one interval and decreasing in two intervals. Both the intervals we should write by the help of union. Let's go to the next problem. Find the interval in which the function f of x is equals to minus 2x cube minus 9x square minus 12x plus 1 is first one, increasing, and second one decreasing. So here also is asking us to find the intervals. He is asking us to find the intervals again, in which this function, a cubic equation, is increasing and decreasing. So let us start the solution. Given f of x is equals to minus 2x cube minus 9x square minus 12x plus 1. So here it is a cubic equation, but this time the highest power of x cube has negative sign. So we should be careful in way we cut. So let me first differentiate. Differentiate f of x with respect to x. So derivative of f of x is f dash of x. This is equals to minus 2 as it is. Then derivative of x cube is 3x square minus 9 as it is. Derivative of x square is 2x minus 12 as it is. Derivative of x is 1 plus 0, because derivative of any constant is 0 here. So finally f dash of x is minus 6x square minus 18x minus 12 minus 12. So if we consider it is 0, if f dash of x is equals to 0, and student, one more thing, let me tell you here, the purpose of considering f dash of x is equals to 0 here is, if I draw the graph of these functions, I get definitely the functions will be of like this. So if I draw a tangent to this curve, the tangents will be always parallel to x-axis. Yeah? The tangents are always parallel to x-axis. So these tangents doesn't have any slope. This tangents does not have any slope. That's the reason we are considering its derivatives are 0. Because we know that derivative is nothing but it is just a slope of tangent, or you can call it slope of line. So since there is no slope to this tangent, because of that reason we are considering f dash of x are 0 here. Okay, let us move further. The moment I consider it is 0, I take this is 0, then this gives minus 6x square minus 18x minus 12 is equals to 0 here. Now here there are 3 terms, but all the 3 terms are divisible by minus 6. Minus 6, minus 18, minus 12. So let me divide by minus 6 here. Divide minus 6 on both sides. So what I get? Just x square minus x minus 2 is equals to 0. So after this, again we should do factorization here. If I'm doing the factorization, then I need two terms whose sum is -1 and whose product is -2. The numbers are x square minus 2x plus x minus 2 as it is. So -2 and +1 are the two terms. Here I can take easily x common, then I will get x minus 2 here, plus 1 is common here. If I remove 1 from this, x as it is, minus 2 is equal to 0. Now x minus 2 is common, then first factor is x plus 1 is equals to 0. So x minus 2 is equals to 0, x plus 1 is equals to 0. So finally I will get x is equal to 2 and x is equals to -1. So I got the two values of x. Let us mark these two values on number 9. Okay. So here it is minus infinity and here we have plus infinity. So plus 2 is nearer to positive infinity, minus 1 is nearer to negative infinity, -1. So here I am getting three intervals. First is 2 to infinity, second -1 to 2, third is minus infinity to -1. Now, student, we should be very careful. Earlier we used to write plus minus plus sign, but in this problem it is totally different, because here the highest power of x has negative sign. In the previous problems we had positive sign for highest power of x, so we used to write plus minus plus, isn't it? But here you got negative sign, so then sign should be minus plus minus, because highest power of x has negative sign, so we should start with negative sign, minus plus minus. The process remains same now. Wherever it is a positive, only that particular interval the function increases, and wherever we write negative, in that particular interval the function is decreasing. So first one, f of x is increasing in the interval -1, 2. Second, f of x is decreasing in the interval -infinity, -1 union 2, infinity. This is the final answer. Because they are negative in two intervals, so that's the reason decreasing in these two intervals. But in positive in only one interval, so it is increasing in -1, 2 intervals. Okay, students, this is about the problems related to intervals. Now let us go to some different type of problems where we can find the function is increasing or decreasing. So let us move on to the next problem. Show that y is equals to log of 1 plus x minus 2x divided by 2 plus x is an increasing function. It is an increasing function. throughout its domain. Throughout its domain. So student, in this problem, he is asking us to prove that this function is an increasing function throughout its domain. Whatever its domain is there, for all those points or for all those intervals, the function is increasing. How can we prove that any function is an increasing function? By finding its derivative, and if suppose the derivative is greater than 0, we will declare the result that function is increasing. If suppose the derivative is less than 0, then we will declare that the function is decreasing. So first we should find derivative of this function. Then we will check whether it is a greater than 0 or less than 0. Solution. Given y is equals to log of 1 plus x minus 2x divided by 2 plus x. Differentiate y with respect to x. Derivative of y with respect to x is dy by dx. This is equals to derivative of log is 1 divided by 1 plus x. If I am differentiating again using chain rule, then I will get 0 plus 1 here. Derivative of 1 is 0. Derivative of x is 1. Minus, if I am differentiating this rational function, I should use quotient rule. This quotient rule says that denominator into derivative of numerator. Derivative is 2 minus numerator into derivative of denominator. Denominator's derivative is 0 plus 1 all divided by square of the denominator. Quotient rule. So finally, my dy by dx is equals to 1 divided by 1 plus x minus 2 2s of 4 plus 4x minus, sorry, not 4, it is 2x. 2 into x it is 2x minus 2x into 1 is minus 2x divided by 2 plus x whole square. So student, here in the numerator, plus and minus x gets cancelled. Plus 2x minus 2x gets cancelled. So at the end, my dy by dx is equals to 1 divided by 1 plus x minus 4 divided by 2 plus x whole square. So here, if you say this is purely a positive quantity. The denominator is purely a positive quantity because of this square. If I give any negative to x, it becomes a positive. And this value will be greater than the numerator value. So it's a proper fraction here. So if it is a proper fraction, its final answer will be always less than 1. Its final answer will be always less than 1. And here, if I put any value to this, its answer is a positive value here. Positive value. If I put even 0 also, it is 1 by 1 is 1. Throughout in its domain, in this particular domain, if I give any value to this, I will get always it is a positive quantity and it is greater than this value. This value will be greater than this value. So its final answer will be always strictly greater than 0. This one, the first value will be a greater value compared to this value. So its answer is always positive answers here. So with that, this is greater than 0. Hence, the given function is an increasing function. Is an increasing function because its derivative is greater than 0. Next problem is prove that y is equals to 4 sin theta divided by 2 plus cos theta minus theta is an increasing function. It is an increasing function of theta in the interval 0, pi by 2. It is a closed interval 0, pi by 2. Student, in this problem, he has given a function y is equal to 4 sin theta divided by 2 plus cos theta minus theta, and he is telling that we should prove that it is an increasing function in this particular interval. In a closed interval 0, pi by 2 means we should accept 0 as well as pi by 2 since it is a closed. Means it is in the first quadrant. In the first quadrant, its derivative is greater than 0. We should prove. Let us see. How can we prove? Solution. Given y is equals to 4 sin theta divided by 2 plus cos theta minus theta. Differentiate y with respect to theta here. Theta is the independent variable. So let us differentiate with respect to theta. Okay. So this becomes dy by d theta. That is equals to, again, for this we must apply quotient rule, and this we can directly differentiate. So what is quotient rule? Says that denominator into derivative of numerator. So it is 4, derivative of sine is cos theta minus numerator into 4 sin theta into derivative of the denominator. Denominator derivative is 0, derivative of 2 is 0, and derivative of cos is minus sine theta, all divided by 2 plus cos theta whole square. And then there is a minus theta, its derivative is minus 1, minus as it is here, and derivative of theta with respect to theta is 1. I wrote 1 here. So our dy by d theta is equals to simple multiplication here. 2 into 4, it is 8 cos theta plus 4 cos square theta, minus into minus is plus 4 sin into sin, sin square theta whole divided by 2 plus cos theta whole square minus 1 away as it is. And now student here, I can easily take 4 common in the numerator. So what I will get? Take 4 common here. 2 cos theta plus, because 4 I have taken common, cos square theta plus sin square theta divided by 2 plus cos theta whole square minus 1 as it is. Now student here, according to first identity of trigonometry, cos square theta plus sin square theta, its value is 1. This can be written as 4 into 2 cos theta plus 1. This complete is 1. Divided by 2 plus cos theta whole square minus 1. Now student, here he said this is in the first quadrant. In the first quadrant, cos is positive. Not only cos, all the 6 trigonometric functions gives a positive answer. Okay. And here, whatever the answer, it is positive and it is finally multiplied by 4. So this complete quantity, we can say that it is greater than 1. Obviously, it is greater than 1. Because here 2 is there and plus 1 is there. Cos itself is a positive here, and here also we will get positive value. This positive value, complete positive value, after multiplying by 4, we will get greater than 1. And that greater than 1, if we subtract with this minus 1, is still greater than 0. It's still greater than 0. So since its derivative, that is dy by d theta, is greater than 0, so we can declare that the given function is an increasing function. So this is, therefore, y is given, y is increasing here. Given function, that is y is function here, is an increasing function in this particular interval, because this interval all the 6 trigonometric functions are positive, and here everything is positive quantity because 4 is multiplied here. Problem. Prove that the function f of x is equals to log of sin x is an increasing function on an interval open interval 0, pi by 2 and decreasing on pi by 2, pi. Student, here in this problem, he has given a function y is equal to log of sin x. Chain rule we must apply if we are differentiating it. And it's telling that this function we should prove that it is an increasing on this interval, that is in the first quadrant 0 to pi by 2. And in the second quadrant it is decreasing. In the second quadrant the same function is decreasing, that we should prove. So let us see how can we solve this. Solution. Given f of x is equals to log of sin x. And so here under the log we know the properties of logarithms. Under the logarithm the value must be always greater than 0. In today's first problem of similar kind of problems proving the function is increasing or decreasing, we discussed one more problem of logarithm there. In that we got log of 1 plus x. Of course minus 2x divided by 2 plus x was there. But here the domain was given is greater than 1. The values of x is greater than 1 here. Or it is greater than 0. The values of x here is greater than 0. Because if you give any negative values here, log cannot define with negative values. So under logarithm we don't want any negative values. It is always positive value. So here if you differentiate this, differentiate f of x with respect to x, what do we get? F dash of x is equals to derivative of log is 1 by sin x. Derivative of log is 1 by x. Next, this sine function is also differentiated. What's the derivative of sine? It is a cos x. So finally, the derivative of log of sin x is cos x by sin x. And we know that cos x by sin x is cot x. Cot x. So student, if we draw the graph of the cot x function here, if I say it is 0, this is x, this is y, negative 1, this is somewhere it is pi by 2 and here it is pi. We know that it is co of tangent, it is reverse of tan. So tan 0 degree is 0 means cot 0 degree is infinity. Somewhere here it goes on. And tan 90 is infinity means cot 90 is 0. Cot 90 is 0. And from here it goes on like this. Or I can mark from here like this. Somehow the graph will be look like this. And this value is goes on because it is infinity. And when it comes to pi by 2 it is 0. Then we will next, if I increase this value, if I go towards 180 degree, it starts decreasing. It will be like this. And again at 180 it reaches to infinity. At 180 it reaches to infinity. So student, it is very clear that in the second quadrant, all the values are negative values of y. See? These are the negative values of y. And in the first quadrant, between 0 to 90, we are getting the positive values of y. isn't it? So since in the first quadrant all 6 trigonometric functions gives positive answer, that is greater than 0 here in the first quadrant, and in the second quadrant cot x is negative, that is cot and tan x is negative, so it is decreasing. So I can write the conclusion that in the interval 0, pi by 2, cot x is greater than 0. That means cot x here is f dash of x, and that is greater than 0. Therefore, f of x is, and right, increasing in the interval 0, pi by 2. Okay, this is first case. Second case, in the interval pi by 2, pi by 2, pi, cot x is less than 0, gives negative values, so it is less than 0, which means our f dash of x is less than 0. The moment I said f dash of x is less than 0, obviously the function is decreasing. Therefore, f of x is decreasing in the interval pi by 2, pi. This is the answer. Student, this is about the problems based on increasing and decreasing functions. I hope you people understood the problems on increasing and decreasing function. If you have any doubt in this kind of problems, you can put your doubt in comment box. And to help other students, keep sharing our videos. If you are new to our channel, don't forget to subscribe. Thank you, student.